Cheers, everyone. I'm back for part 2 of day 3. So someone asked why I drink this. I drink that because this powers all programmers. No, I drink it because I teach a lot of courses, and I find that if I don't lubricate my mouth, I go sounding raspy. So just one thing I tend to teach a lot of my students is take care of your body, right? I mean, you only have one set of hands, eyes, back, etc. So do things like if you need to get a different keyboard, get a different keyboard, right? Or if you need to get a different chair or a standing desk, do that. I've drawn a lot of, I don't know, Twitter rage over my chair, and I would say find what works for you. I have a old, like a 40-year-old wooden chair that I use generally. I'm in the process of refinishing it, so I've got this modern ergonomic chair that I'm using right now. So hopefully that makes my coding better. And like for me, I don't really find that much difference between the chairs. I find that it's more my posture, not actually the chair. But you know, do what works for you. If you like a fancy chair and it makes you feel better, do what works for your body. Okay, so enough ranting here. Let's do part 2 of day 3. Okay, I'll just slide this over here. Let's see if I can read this. Time to check the rest of the slopes. You need to minimize the probability of a sudden arboreal stop after all. Determine the number of trees you would encounter if, for each of the following slopes, you start at the top left corner and traverse the map all the way to the bottom. Right 1, down 1, right 3, down 1. Right 5, down 1, right 7, down 1, right 1, down 2. In the above example, these slopes would find 2, 3, 4, and 2 trees respectively. Multiplied together, these would produce 336. What do you get if you multiply together the number of trees encountered on each of the listed slopes? Okay, so this is just a play on what we did earlier today. Let me just swap my screens around here. Okay, so here's day 3, right? And this is our tree counts code. I'll make this a little bit bigger so you can see. See all the logic there. Okay, so there's all the logic for figuring out that count. I'm going to go over to my test here, test day 3, and I'm going to make a test for test part 2. Def test part 2. Okay, and basically what I'm doing here is I'm getting my tree map that I have above here, and I'm going to loop over those values that it said here. So we find all these numbers and we get the product of them. Cool. So I'm going to append all these values into a list, and then I'll do some functional programming and we'll sum the list with functional programming. It just allows us to sum it in one fell swoop instead of looping over it and doing the product that way. Okay, so I'm going to make a little for loop here that's going to have, so one thing you might not know of is unpacking. Python has a notion of tuple unpacking, so I'm going to say for right, comma down in, and I'm going to loop over a list here, and it's going to be a list of tuples. So the first one is 1, comma 1. That should give me that first one, and then we're going to have 3, comma 1, and then we're going to have 5, comma 1. 7, comma 1, and I'm getting at the end of the screen here. Oh, I'm getting some wrapping here. So what's after 7, comma 1? And then 1, comma 2. So here's what I'm getting for res, and I'm just going to make a variable here. It says these are the counts. It's a list. And then I'm going to come down here, I'm going to say counts.append. And then instead of saying 3 here, I'll say right is right and down is down. Let me just show one more thing that you might want to do if you're not familiar with this. So Python 3 has the notion of keyword-only arguments, which are really nice for reading, making your code more readable. So if I put a star here and put that after here, what that means is I can't call this without passing in the keyword. So for example, up here in this one up here, if instead of saying right here, let me just change this. I'll comment out this test and we'll run this. Okay, so let's run the test here. And why didn't it complain? Should have complained. Oh, I didn't save it. Yeah, let's save it. Okay, and so now we get this type error that says that tree counts takes 1 positional argument, but 2 were given, and 1 keyword argument was given. So why would I force someone to do something like that? What I like to tell my students is that you want to focus on making your code readable. And so just having a 3 here, just having a 3 there is not super useful. And so if you force it to have a parameter, it's going to make it more easy to read. So the 3 is what we call a magic number. It has meaning to you as you're reading it, and doesn't necessarily have meaning to the person who's going to be reading your code in a month or in a week from now. So you want to optimize for people who are reading your code later, not optimize for people who are reading your code today or necessarily for yourself, if that makes sense. And I'm not quite sure why I killed this, but let me open back up here. Okay, so here's test and okay. Okay, so what I want to do is come back down to this 3 right here and change this to right. So that just makes sure that I know that I'm doing right there. And if I go back to my test now and run my test, I don't have any failures. Okay, so what I'm going to do down here is we're going to import functools. Now, functools is in the standard library. Day3 is a local library. So what I'll do is I'm going to put functools just up above that. Why do I do that? PEP 8, which is Python Enhancement Proposal 8, which really is an enhancement proposal, but it's a document describing best practices and coding conventions in Python, recommends that when you have imports, you alphabetize them, but also you group them. So you do a group by if they're in the standard library, third party, or local, and then you alphabetize them in those groups. Okay. So functools will give us the result there. And then what we're going to say is assert that functools.reduce. And I believe reduce takes a function as the first parameter. It's a higher order function that takes a function as the first parameter. So I'm going to say we're going to pass in a lambda here. And the lambda is going to, this lambda is going to take 2 values and it's going to multiply them. Okay, so the reduce function takes it's a higher order function, so it's a function that takes a function as input. This is a little brain twisting for people who aren't used to these functional constructs here. We're passing in a lambda function, which is an anonymous function, but we're passing in the function. We're not calling the function per se. But what this function is going to do is just going to take two things and multiply the two things together. The reduce will go through every item in there and it will call with the first two parameters in your sequence that we're going to pass in, it will call the function with the first two parameters, take that result and call the function again with the next parameter and pass in that first result and the next parameter and apply that again and keep doing that. So this will just give us the product of everything in there. So we're going to apply that to counts. And I don't know what that's going to be. I'm going to just make it fell here. I mean, I could make it do whatever, but I'm going to make it fell, and then let's run this and let's see what this gives us. Okay, so it looks like it passed. That's because I didn't change the name of my function here. So for Pytest, to find this test, it needs to start with test underscore or end in underscore test.py. Okay, and what did we get here? We got an assertion error. Interesting. Okay, oh, there's the number there, this 5 whatever. Okay, so this is a little bit hard to read, whatever this number is. Let me show you another feature of Python 3 that will make this easier to read here. So here's our number, and I'm just going to make this on, I'll just remove the split here. So here's our number here. Python 3 has this nice feature where you can insert arbitrary underscores here. So what I like to do is put them in where you'd have a comma. We can't use a comma because a comma is used for tuple designation, and so can't use that, but we can use underscores there. And Python just ignores those, but we can use that, like I said, to make our code more readable. Okay, so that looks like it works now. Let's go back to our advent of code here and check if this, this value is the right one. Yay, correct answer. Awesome. Okay, so for this part 2, we didn't change the code at all. We're still using that tree counts code. All we did was we created a loop where we're passing in these different parameters. We looped over them. We use this nice feature of Python called unpacking here. So because we have a tuple, we're looping over each tuple, right? So we're looping over this list, and that's giving us every item in the list. In this case, the items in the list are tuples. And rather than just making a single variable pointing to the tuple, we're doing what's called tuple unpacking directly in the for loop. One thing a lot of people aren't aware of in Python, when you do a for loop, you create a variable, or variables in this case, because we're creating two variables right and down inside that for loop. Neither of those will be garbage collected after the for loop is done. There'll be local variables in the local scope, and they'll be garbage collected when that goes away. Okay, and then what else do we do? So we got that list with all the numbers in it, and then we did our functional program here to multiply those out. Again, you could do a for loop and loop over them and do repeated multiplication with that, or alternatively, like you could start at 1 here and just do total is 1 and do a total star equals whatever this result of tree counts is. I didn't do that because I wanted to have this counts here in case I need to debug that and look at the intermediate values there. But yeah, that could be another way to do that. In fact, let's, instead of ending right here, let's just for funsies show maybe if you want to like enter the Coding Terseness Hall of Fame, and you're like, hey, I want to make it 1 line of code instead of this many lines of code. Let's just I'm going to refactor this and make another one that is using a list comprehension here. So from here, this you see that we got an empty list here, and then we're appending into that list. So that tells us that we can use a list comprehension there. Let me just show you how we would make the list comprehension. We're going to take our for loop here, and we're going to plop it into here, and we're going to take off the colon from the end of that. Now, whatever we're appending into this, which is this down here, we're going to plop this, and we're going to stick this at the very front of our list comprehension. Okay, I've got an extra parenthesis, or yeah, a closing parenthesis at the end, so I'm going to get rid of that. I'm also going to, this is one line, but I'm going to put this for loop on the other line. So this is what we're aggregating right here, and then we're looping over this. So just for fun, I'll just leave this like this, and let's rerun this and make sure that this works. I didn't break anything in this refactoring. Okay, that does work. We can go one step further now. So you see how we're using counts right down here. We could just take this whole thing and we could plop it into here. So you Lisp people out here in video land or Clojure people, this might be like something what you would do. Okay. Is this hard or easy to read? I'm not necessarily, I'm not proclaiming that this is like easy to read per se, but it is, I mean, basically this assertion is one line of code here. So we're reducing the lines of code here, and it still works. Okay. Would I do that? I think this is a little bit harder to read, and like I said before, I don't necessarily optimize towards making things easy to write. Is this easier to write? I don't think this was easier to write. Like, I didn't write this in the first case either. I also don't necessarily think that this is easier to read than what we had before. But I'll leave this in here. I think this is a useful exercise because it demonstrates that pattern of finding list comprehensions. I think I do like the list comprehension that we had before this. I just think that throwing that into the func tools reduce with the lambda there makes it probably a little bit hard to read. So I'll leave that with you. Anyway, cheers. Hope everyone's doing well. Stay safe out there. Take care of your bodies and whatnot. And hope you enjoyed this video. We'll see you hopefully tomorrow with another one.